Welcome back. Today we follow a team of fabricators as they build a massive industrial storage silo from raw, rusted steel sheets. The sheer scale of the tank demands precision engineering at every stage. The process begins by stripping heavy oxidation from the perimeter of a conical base section. An angle grinder exposes bare metal, which is critical for structural integrity, welding over heavy rust traps, impurities in the joint, compromising the bead and risking future failure under load. Shaping thick steel plate relies heavily on mechanical advantage. Suspending the massive panels from a central chain hoist allows the crew to manipulate the curvature with targeted strikes. Hand forming the initial radius relieves internal tension in the metal before it is fed into the industrial roller. A long steel lever is used to pivot the unwieldy cone into position. Once aligned, the base ring is tacked and fully welded. This solid steel collar distributes the immense vertical load of a full tank evenly across the foundation. Before any permanent fusion occurs, the mating edges are hammered flush to eliminate gaps that could weaken the weld pool. The curved sidewalls are then joined using intense arc welding to lock the cylinder together. Inside the shell, a radial layout of support struts braces the structure. Cylindrical pressure vessels require these internal skeletons to resist inward buckling and maintain their geometry under heavy atmospheric and fluid pressures. As the assembly progresses, the focus shifts to sealing the interior seams. The craftsmen run continuous beads along the inside of the joints, a process that ensures deep penetration into the root of the weld. Dual-sided welding prevents microscopic voids and protects against internal corrosion over the lifespan of the silo. The sheer size of the chamber amplifies the heat and fumes, making the enclosed work physically demanding. By the time the cone cap is fully integrated, the primary structural envelope is complete. The raw steel now holds its final monolithic shape. An aging but effective industrial roller bends solid bar stock to match the exact radius of the tank. These curved metal ribs are then hoisted up and welded directly to the exterior shell, adding external reinforcement bands significantly increases the structural rigidity of the thin-walled cylinder. The ribs act as stiffening rings, interrupting the flat planes of the metal to prevent deflection when the silo is exposed to high winds or loaded to maximum capacity. Every added bar brings the vessel closer to strict industrial tolerances. Closing the enormous cylinder requires precise coordination. The heavy steel end cap is leveraged into the opening, while a chain hoist applies mechanical tension to pull the massive plate perfectly flush. Once seated, a continuous circular weld seals the perimeter. This final cap must be perfectly aligned before the torch is applied, as any unevenness in the seam could create a concentrated stress point. The continuous bead effectively makes the two separate plates perform as a single continuous surface. To install utility connections, precise access ports must be carved directly through the hardened steel. The worker lays out the dimensions using chalk and a metal template, ensuring exact clearance for the upcoming hardware. The oxy-fuel torch is then used to pierce the hull. Rather than melting the metal, the intense heat of the torch brings the steel to its kindling temperature, and a blast of pure oxygen rapidly oxidizes and blows the material away. The resulting cut is aggressive but highly controlled. Afterward, the raw edges are meticulously beveled and smoothed to remove slag, providing a clean mating surface for the pipe fittings. Heavy utility pipes are hoisted and aligned with the freshly cut ports. Tack welding holds the massive red plumbing in place, while a heavy reinforcing collar is fitted around the base. Welding directly to the thin tank wall risks tearing under the weight of liquid-filled pipes. The collar acts as a dabbler plate, distributing the shear forces over a much larger surface area of the hull. The final weld fuses the pipe, collar, and tank into an integrated, leak-proof assembly capable of handling heavy industrial flow. The transformation from raw, scarred steel to finished industrial equipment relies entirely on the surface coating. A high-pressure sprayer applies a thick layer of industrial blue enamel. This coating is far more than cosmetic. The heavy paint acts as a critical barrier, sealing the steel against moisture, and preventing the aggressive oxidation that would otherwise quickly compromise the vessel. Careful touch-ups are applied to the welded joints and pipe brackets, ensuring that no microscopic pores are left exposed to the elements. The metal is now fully armored. As dusk settles over the yard, the completed silo is rigged for its final departure. Maneuvering tons of steel requires steady hands and quiet coordination. What began as a pile of rusted, flat plates is now a precise, high-capacity industrial asset, revived through thousands of calculated welds and careful geometry. It is a structure built to endure, honest in its construction, and ready for decades of heavy use. The massive tank finds its place on the transport, heading out into the night to begin its working life.